Okay, I'm going to briefly go through the standard error of the mean and help you to understand it. Remember that when we had a group of scores or data points, we could figure out the average or the mean of all those data points. Then we figured out the standard deviation, and that told us how much variance there was in that group of scores, how much variance there was between the scores and the mean overall as a group. Now, when we take a distribution of means or a group of means from several samples based on that underlying distribution, we can also come up with their average. But instead of using standard deviation, we use the standard error of the mean. It tells us exactly the same thing as the standard deviation. It tells us how much variance there is in that group of means in all those theoretical samples. Why? Why do we care? Well, when we look at the sampling distribution of all those means on that underlying distribution, the sample size that we pull affects the variability. If we pull larger samples from out of the population, our variability decreases. In other words, the mean gets closer and closer. The mean of every sample, larger samples, gets closer and closer to what the mean is for the population. So as the sample size, as n, increases, the variability decreases. In other words, the error in our samples goes down. Let me repeat that. As if we pull a whole bunch of samples and compare their means from out of a population, if we pull little tiny samples, the means of each of those samples is not going to be as close to the mean of our population. They become more accurate if we pull larger samples. It also means that as the sample size, n, increases, the distribution in that sample that we pull becomes more and more like a normal distribution in shape, even if the population distribution wasn't necessarily normal. What this means is that instead of a standard deviation, when you're working with a group of means from all these different samples you've pulled, let me back up. Remember, you would never pull all those samples. This is all theoretical and it's all based on math that's already been done. But when you figure out the standard deviation, which isn't standard deviation, it's standard error of the mean, you have to divide the variance by the square root of the size of your sample. So why? Well, what we're going to do is simply use a z-score again to figure out the probability that our sample will have a particular mean, or that the probability that our sample will have a mean within a particular range. And your textbook gives you several examples of that. So instead of the standard deviation to figure the z-score, remember we're going to take the difference between the mean for our sample and the mean for that we know that's for the population. We divide that by the standard error of the mean instead of the standard deviation.